In business statistics, we will be seeing calculation of regression equations using regression coefficients. In this lesson, we will be looking into some more problems for calculating the regression equations. And we have assignments as usual. So if you practice all these problems and assignments, hope you will understand more about the regression equations. So in this lesson also we have regressions in detail. So in this lesson, as I said, we'll be practicing more problems on regression equation, which are obtained through regression coefficients. Of course, by any method, most probably assumed mean. And since the regression analysis is the last unit in our syllabus, so we will be concluding the regression analysis in this lesson. And as a result, we will be completing the business statistics syllabus. So for better understanding of the subject, you will be studying these video lessons again and again so that you can understand better. And you have to practice more problems. This is since this is a problem oriented curriculum syllabus, you have to practice more to understand the subject more. Right. In the last lesson, we have seen the properties of regression coefficients. To quickly recap the properties, regression coefficient should not be greater than or less than 1, that is, or greater than 1, that is minus 1 and plus 1. That should be less than 1, whether it is negative or positive. So calculation of correlation coefficients, we have seen the method of obtaining the equations by calculating the regression coefficients. And we have also seen the formulas also. We have seen 3 methods, that is direct method and shortcut method by taking actual mean and shortcut method by taking assumed mean. So in this lesson also, as I said, we will be dealing with more problems on this topic. We have seen the steps to be followed when taking deviations from assumed mean. First of all, we have to obtain the assumed mean by looking at the series given in the problem. Then take deviations of X series from assumed mean of X and denoting it as dx, and square these deviations to obtain sigma dx square. So if we take total of dx deviations, we will get sigma dx, and if we calculate the totals of squares of these deviations, we will obtain the total of sigma dx square. And similarly, taking deviations of y series from the assumed mean of y and denote these deviations as dy. So after this, you total the deviations to get sigma dy, and then you will be taking squares of these deviations of y series by obtaining the total as sigma dy square. And then in the last column, we will be taking the product of dx dy, that is dx into dy, and then add the total of dx dy. Then we will get sigma dx dy. So all these values are taken and the values are substituted in the formula to get the regression coefficients, and finally we will get regression equations. So we will take one example again and then we will work out these problems. So in this problem also, marks for 50 students, 50 boys in a French and Germany test are given. And assuming that there is a linear relationship means correlation exists. Correlation is there. So X series and Y series are given. And then first assume the means of X series and Y series. We have to take assumed mean A of X and A of Y. We can take any value from this series or any value you prefer. So you please remember, by taking the assumed mean, you should reduce the calculations involved in the problem. So if you take any other value just like that, the calculations may increase, which will burden you. So you always prefer a value which will reduce the calculations. So in this you can take, for example, X series 28 or 33 because both are middle of the series. So that you can get 0 at one point and minus and negative and positive values. And in the Y series also, in the same way, 35 or 27 can be taken, or 35 and 33 can be taken, so that you can take the deviations. So we'll see in the next slide what we have taken. The calculation of regression equation, first we have to calculate the mean given, that is of X series and Y series. So sigma X is 282. This mean is useful because we have to uh, use them when we are calculating the regression coefficients and their equation. Of course, for equation it is required. X on Y series equation is x minus x bar is equal to correlation of standard deviation of x by standard deviation of y into y minus y bar. So in that x bar and y bar is required. So x bar is sigma x by n, that is 282 by 10 or 28.2. So we can take basis of this by taking nearest value of mean to reduce the calculations. This is another method of taking assumed mean. So assumed mean is taken as 28 for X series. And then calculate mean for Y series, that is sigma Y is 298 by n 10, that is 29.8. We can take 30 as assumed mean, nearest one. So assumed mean is taken as 30. Like this you can take the assumed mean so that the calculations may be reduced. So as usual, we will be drawing a table to get all the values which are required for calculating regression equations and also regression coefficients. So in the first column, we have taken X series. In the fourth column, we have taken Y series. In the second column, X minus A, that is to obtain dx, X minus A is required. So X minus A minus 18, that is 28 assumed mean we have taken. So 10 minus 28, 10 minus 28, 18 minus 28, 25 minus 28, 28 minus 28, 33 minus 28, 34 minus 28, 39 minus 28, 42 minus 28, and 43 minus 28. Then we can take sigma dx to get total of the dx column, that is plus 2. And then in the third column, we will be taking squares of the deviations which are obtained in second column. That is minus 18 into minus 18, 324. Again minus 18 into minus 18, 324. Minus 10 into minus 10, 100. Minus 3 into minus 3, 9. 0 into 0, 0. Plus 5 into plus 5, 25. Plus 6 into 6, 36. Plus 11 into 11, 121. Plus 14 into plus 14, 196. Plus 15 into plus 15, 225. And to obtain the total sigma dx square. So after obtaining the sigma dx square, we will go to the y series now. Y series, again deviations are taken by assumed mean. We have selected 30 as assumed mean. So assumed mean is taken for y series, that is 11 minus 30 is 19. And remaining deviations also we will be taking similarly by deducting the y series value from the assumed mean, that is 30. So after obtaining all the deviations, as usual, we will be taking product, the sum of the dy series. And then after taking the sum of the dy series, we will take squares of the deviations in the next column. Deviations of y, squares of deviations of y. That means minus 19 into minus 19, minus 8 into minus 8, minus 8 into minus 8, like this. We will be taking dy squares, that is sigma dy square. So we have obtained the dx dy, dx and dy, sigma dx square and sigma dy square. Now in the last step, we will be obtaining the product of dx dy, that is minus 18 into minus 19, 342. Minus 18 into minus 8, 144. Minus 10 into minus 8, plus 80. Like this, we will obtain dx dy. So sigma dx dy we will obtain. That is 135. 1135. Sorry, 1135. This is 1135. Substituting these values First we will obtain bxy and byx. So the formula is sigma dx by dy minus sigma dx into sigma dy by n, the whole divided by sigma dy square minus sigma dy whole square by n. This is to obtain bxy. So after obtaining bxy by substituting the values, we will get the value of bxy plus 0.958. So as we have seen in the previous lessons, if we get bxy as positive, byx also we will get as positive. If byxy is negative, byx will also be negative, right? So bxy is 0.958. Similarly, we will calculate byx also. So byx also we will calculate from this series like this: sigma dx dy minus sigma dx sigma dy by n, sigma dx square minus sigma dx by n whole square, that is whole square, sigma dx by whole n whole square. So this is whole square, not this one. This is whole square, not simple by n whole square. Okay. So after obtaining this byx, we will substitute the values and then we will get 0.835 plus 0.835 byx. So we have to substitute these values in the equation. Now we will obtain the equation x on y. So x on y is x minus x bar is equal to bxy into y minus y bar. So the actual mean is 28.2 for x and 29.8 for y. So x minus 28.2 is equal to 0.958 into 1 y minus 29.8. So we got the equation as x minus 28.2 is equal to 0.958 y minus 28.55. So we got this equation. This is equation number 1. 0.958 y minus 0.35. Equation number 1. Similarly, we will calculate equation number 2 also. Number 2, byx y minus y bar is equal to byx into x minus x bar, that is y minus 29.8 is equal to 0.835. 0.835 is byx into x minus 28.2. So we get the equation y is equal to 0.835x plus 6.253. So if you are asked to calculate the values of x given y or y given x, then we have to calculate by using these equations. Next, we will take another example from the given data. uh, Calculate regression equations by taking assumed mean as x is equal to 3 and y is equal to 2. These are given in the problem itself. So we have to take x is equal to 3 and y is equal to 2. And after obtaining the equations, if x is equal to 5, then find out the y value. So the series is taken, mean is taken, sigma x is 23 and n is 8. So sigma x by 9, n is 2.875. And y mean, y bar is equal to sigma y by n, that is 16 by 8, 2. So calculation of regression equations. As usual, we will be preparing table and calculating dx, dy, and we will obtain the values of sigma dx, sigma dy. Then we will take squares of dx and dy, that is dx square and dy square. And finally, we will take product of dx dy by taking sigma dx dy by dx, sigma dx dy. So we have obtained all the values of regression coefficients and regression equations. We have to substitute all these values in the formula to obtain regression coefficients, that is bxy, byx, and then we will also calculate regression equations by using these values. So bxy is calculated as minus 0.304. So byx will also be minus, and byx minus 0.304. bxy is 0.304 and byx is also 0.304. That is only a incidental one. So both are same. So equations x minus x bar is equal to bxy into y minus y bar. So the equation is x is equal to minus 0.278y plus 3.431. So we will calculate y equation also. So the y equation is y is equal to minus 0.304x plus 2.874. So we have to obtain y value when x is equal to 5. So we will substitute this x value in y equation. y on x. When x is given, x is independent and y is dependent. So y is equal to that equation we have to take. So we got 1.354. The value of y is 1.354. That is decimal. So this is the method of calculating the regression coefficients and obtaining regression equations from the given series. And we have to estimate the values of x and y when it is given. Another example, same, obtain the two regression equations and determine the most likely internal mark for the end exam mark of 25. That is, when x is 25, when y is 25, calculate x. That means x on y. We have to calculate x on y. And the most likely end exam, y on x also, when x is equal to 30, y value calculation. So both we have to calculate. We follow the same method which we have seen in the earlier examples, two examples. So let the internal marks and end exam marks are x and y respectively. So internal marks are 35 actual mean, end exam marks actual mean is 29. So if you take assumed mean also, we can take 35 and 29 as assumed mean. So here x minus x bar is taken. Actual mean is taken for calculation of regression coefficients and regression equations. So we have to obtain sigma x, sigma y, sigma small x, sigma small y, and sigma x square we have to obtain, sigma y square we have to obtain, and finally we will obtain xy to get sigma xy. So after obtaining these values, we have to calculate the regression equations. So first we will calculate the regression coefficients and then we will calculate the regression equations. So the line of regression equation of y on x is y is equal to 0.905x minus 2.675, and we will also calculate the regression equation of x on y, that is line of regression or regression equation we have to calculate. So we are getting x is equal to x is equal to 0.542y plus 19.28, and we have to calculate the values. Most likely internal mark for end exam mark is 25. That is y is equal to 25 and we have to calculate the x. That is x on y. We have to take x series. X is equal to 32.83. When y is equal to 25, x is equal to 32.83. We have to calculate even other also. When x is 30, y is 24.475. So another example we will take and calculate the two regression equations and the coefficient of correlation between the marks in economics and statistics. So marks in economics is taken as x, marks in statistics is taken as y. So the most likely marks in statistics when marks are in economics are 30. So x is equal to 30, we have to calculate y. So as I said, economics is taken as x and statistics is taken as y. Similarly, we will take the table also and calculate all the necessary required values to substitute these values in the formula. We have taken the values of sigma x square, sigma y square, sigma xy. We have taken actual mean to calculate the regression equations. Here, you remember one important point. Anyway, we are calculating the actual mean. So if actual mean is we are getting in fraction, that is decimal points, then you can take assumed mean. If actual mean is round figure without any decimal points, you can take decimal actual mean value only. Then calculation of regression of coefficients will be taken. So like this you can understand and you can apply the formula. Any method you can follow, but this is preferable. This method you can follow. So we got x bar is 32. So byx is minus 0.6643 and bxy is actual mean is x bar is 32 and y bar is 38. So we have substituted the values and obtained the x and y equations to obtain the values when x is equal to something. X is given, y you have to calculate. So y is equal to we will calculate. We have to calculate y. Then we have to calculate correlation coefficient also, byx and bxy. So R is equal to minus 0.394. And finally, we will calculate x is equal to 30, y is equal to 39. By substituting the values we have obtained in the equation, we will get 39. So like this, you can practice any number of problems. Here in another example, a different model. We need not calculate all the values by taking tables. From the given values, we will calculate the required value. So arithmetic mean and standard deviation is given. Then it is very easy to calculate bxy and byx. Arithmetic mean is x bar is 36, y bar is 85, and standard deviation standard sigma x is equal to 11, sigma y is 8. So correlation coefficient between x and y 0.66 from the data given. Find the two regression equations. So estimating the value of x when y is equal to 75. So regression equation of y on x, y is equal to 0.48x plus 67.72. And x series, so value of x when y is equal to 75. When x is when y is 75, x is equal to 26.92. Another example we will take. Like this, you can work out any number of examples and obtain the required values, and you can also work out the assignments. So another example is the correlation coefficient between the variables x and y. Find the equations of y on x and x on y. Then as usual, these equations are taken and we have to calculate the regression lines y on x, x on y. Similarly, we will take another example. Byx is 0.4, bxy is 0.9. Find the value of correlation coefficient, that is r is equal to root of bxy into byx. These are short answer questions, that is 1 mark question. So 0.4 into 0.9 under root, 0.36 under root, 0.6. So r is equal to 0.6. Another example, means are 68 and 150, that is x bar and y bar are 68 and 150. Standard deviations sigma x 2.5, sigma y 20. Their correlation coefficient is 0.6. And we will calculate the equations. Another example we have taken. For some bivariate data, the following results were obtained. So again, arithmetic mean of x and y are given, and we have to calculate other values. So like this, you can work out the problems, and we will work out the assignments given. Here I have given you sufficient assignments. You can work out to understand the topic very confidently, to work out the problems very confidently. And with this, we have completed the regression equations or regression analysis unit also. And finally, we have completed the syllabus for business statistics. So I have worked out as many examples as possible, and as many assignments are given. So if you have practiced all these examples and assignments, I hope you will be thorough with the subject and you can score good marks. If you have any doubts in these lessons, of course, you have to excuse me for small errors, if any, in these lessons, because even though I have taken utmost care to prepare the lessons, some errors might have creeped in. So if you find any errors, you please excuse me. And if you have any doubts regarding this subject, business statistics, or any of the topics, you can clarify with your subject lecturer, subject teacher, or you can contact me over phone so that I can explain you to the possible extent. So hopefully your subject teacher will be having my mobile number, so you can take that number and contact. So with this, I conclude the syllabus. To quickly summarize the syllabus, what we have seen in this subject. In the first unit, we have seen Introduction to Statistics, in which we have seen meaning, definitions, functions, importance, and the limitations of statistics in detail. And we have also understood what is frequency distribution and how it can be tabulated, how it can be done by preparing the table tabulation form. And we have also understood the graphic presentation of the data by preparing the diagrams and graphs. In the second and third units, we have seen measures of central tendency. There are five averages, five types of measures of finding the central tendency, and those are arithmetic mean, geometric mean, harmonic mean, median, and mode. So in the second unit, we have understood what is arithmetic mean, how to calculate it, and what is geometric mean and how to calculate it, and what is harmonic mean and how to calculate the harmonic mean. And in the process, we have understood what is combined arithmetic mean and what is weighted average arithmetic mean. In the third unit, we have learnt about the calculation of median and mode. And in this unit only, we have learnt about the calculation of quartiles, deciles, and also percentiles after learning the median. In the fourth unit, we have learnt about the measures of dispersion, in which we have seen what are measures of dispersions and meaning, definitions, objectives of dispersion. And we have seen different measures of dispersion. They are range, coefficient of range, quartile deviation, coefficient of quartile deviation, mean deviation and coefficient of mean deviation, standard deviation and coefficient of variation. So we have learnt all these things in the fourth unit. And in this, for examination point of view, all these are important. And for further higher education, standard deviation is most important. So you understand the standard deviation very well, so that the same standard deviation are used in correlation and regression also. In the fifth unit, we have learnt about the correlation coefficient, in which we have seen two methods, that is Carl Pearson's method and Spearman's rank correlation method. We have also seen the concepts of correlation by understanding the meaning, definition, and uses of correlation. And we have also seen different types of correlation. And in last unit, finally, we have seen about the regression analysis. So in regression analysis, we have seen meaning and utility of usage of regression analysis. And we have also seen what are the differences between correlation and regression by comparing the concepts of correlation and regression. And we have calculated regression equations by taking regression coefficients. We have also seen diagrammatic part of obtaining regression lines. In correlation, we have seen about the scatter diagram also. In regression analysis also, we have seen the graphic method of obtaining regression lines. And in all these units, wherever required, we have practiced sufficient number of examples and sufficient number of assignments. So I hope you have understood the subject. And as I said, if you have any doubts, you can contact me or your business statistics lecturer to clarify. So with this, I will end the subject of business statistics. So all the best for your examination. Hope you will secure good marks in business statistics, and all the best for your future comes ahead. Thank you very much.